let's start with the next topic, that is Boolean Algebra. So the learning objectives of this lecture will be, you will learn the difference between the mathematical algebra and Boolean algebra. What are the laws and postulates in Boolean algebra and how to minimize the logic functions using Boolean algebra. The topics to be covered is Boolean variables, Boolean operators, Boolean laws and postulates, Boolean rules and simplification of the functions. First of all, understand what is Boolean algebra. So Boolean algebra is the set of rules which are used to simplify the given logical expression without changing its functionality. As we know that algebra in a mathematics deal with symbols and their rules. So in 1847, the George Boole introduced Boolean algebra. What is Boolean algebra? It is a set of rules which are used to simplify the given any logical expressions, but without changing its functionality. Means its functionality remains the same, but you will reduce the logical expressions using the set of rules. That is known as Boolean algebra. So how Boolean algebra is different from the mathematical algebra? See, mathematical algebra deals with the numerical operations, whereas Boolean expressions are dealt with the Boolean algebra. Means Boolean algebra deals with the logical operations. Okay, mathematically algebra, numerical operations, and Boolean algebra, logical operations. Just like disjunction, conjunction, negation. Whereas in mathematical algebra, we usually used addition, subtraction, multiplication, division, etc. Only two values are used in case of Boolean algebra. One is low, other one is high. As I have told you earlier also that in digital electronics, logic 0 is represented by 0. High, logic 1, pass, success, everything is represented by logic 1, means value 1. So, in short, we can say that Boolean algebra is used to explore the digital circuits and systems mathematically. Again, it is a set of rules which simplify the given logical expression, but its functionality will not change. If I say f equal to ab plus bc plus cd, and at last if you are getting a plus b into d, it means the both functions will work in a same manner, although expression is reduced. Now, what are the advantages of Boolean algebra? The main advantage of Boolean algebra is it is used to simplify and minimize the logical functions. Because now the reduced function is there, so it will consume lesser space. Because less wire will be used, less space will be used. Okay, so less power will be consumed. If it is consuming less power, if it is consuming less space, lesser power dissipation, so it will be fast. Okay. Now you may also think that what are the disadvantages of Boolean algebra? So the main disadvantage of Boolean algebra is that it is used when the number of variables is less. Number of variables are less means, for example, 1, 2 or 3 variables, A, B, C is as in input. But if the number of variables are larger, means many variables are involved, then it is not a wise decision to use the Boolean algebra for reduction. In that case, we will use Carnot map. And second thing that is a disadvantage for, we can say, for the Boolean algebra is, for example, a function is given. So each and every student or candidate can reduce it by using a different set of rules, because there are so many rules are there, and it's not predefined that it will become to the 4 steps or 5 steps. So each of us can get a different kind of answers also, and we have to verify the answer using the truth table. So it may be one of the lacking point in case of Boolean algebra. So although there are no restrictions on Boolean variable, but the values will be remain 2, 0 and 1. As I have told you earlier also that 0 means low, false, no, off, whereas 1 stands for high, true, yes and on. Okay. Operators will remain the 3, and or not. Okay, not is also known as complement or inversion. means if you are giving input A, you will get A bar. OR means where you are just adding two numbers, and AND is multiplication. So Boolean expression, it is a logical statement which is either true or false. Or we can say that expressions are used to compare the data of any types. Or you can compare the two data sets, or you can say that it is a bigger one, it is a smaller one, it is the same. And there are two ways to express the Boolean expressions, Boolean equations. One is SOP and other is POS. If I say SOP, I mean to say sum of product, just like AB plus BC plus CD. In case POS, it is product of sum, means A plus B into B plus C into C plus D, in such a way. So let's start with the Boolean laws and theorems. These are the few Boolean laws. Main are not involved with not, or, and. You will see it is not, or, and. And further, there are commutative law, associative, distributive, and theorems are there, just as DeMorgan's theorem, consensus theorem, etc. So let's understand these things. Okay, before going further, I would like an example to show how an expression is made. For example, I want to purchase a laptop from a specific shop. Okay, it may be the reason that that particular shop is selling the laptop on the cheaper price, means cost matters. Or we can say this shopkeeper is known to me, so that I am assured that it is a genuine product. So I can say known person is there. And one more thing can be there, that there is no other shop nearby my area. That's why I want to purchase it from a specific shop. Maybe after 5 kilometers far away or 10 kilometers far away, but I want to purchase a laptop from that person only. So it may be good shop is not near my home. Means it is not nearby my home. If these two are fulfilling, then I say that I am getting a laptop from this person. This is the AND. Again, understand the thing. For example, I want to purchase a laptop from a person named XYZ. It is far away from my home. Now, what may be the reason? It may be the reason, maybe it is cost effective. Maybe that person is known to me. Or there is not a good shop nearby my home. That's why if these conditions are fulfilling, that's why I want to purchase it from a specific shop. Now, for example, it is A, it is B, and it is C. So how I can make a expression for this A, B, C and Y? Okay, let us see how to make a function, how to make a Boolean function, or how to make a expression here. See, it is or means plus sign, A plus B, because and is there, so it is dot. Because not a good shop means it is a complementary form. It is equal to Y. So you can say that the expression of Y can be equal to A plus B into C bar. This is known as Boolean function or Boolean expression. Okay. So this is the case, means how we can make a Boolean expression. Now let's start with the different theorems or different set of rules. What are those different set of rules? I'm starting with the first one. Rules number 1, that is complement. Okay. Now complement. Complement is A bar, or you can write it as A. Put this bar sign over here, or you can write it as not of A. It means each and everything is same. Here if I say that complement of 1 complement is equal to 0 and 0 complement is equal to 1. One thing is for sure. So complement means not rules. Basically, if you see that rules are associated with three things, not, and, or. I am starting with the not format rules. In not format rules, first of all, we are starting with the rule A bar bar, A double bar. Now we will see what is the value of A double bar. Now let's take the 0 bar. 0 bar is 1. Again you are taking the complement, it will equal to 0. Means the same value you are getting that you are starting with. Or for example, I am having 1. The complement of 1 is 0, and again when you are taking the complement, it is equal to 1. It means that whatsoever the value you are taking the double complement, you are getting the same value. So A double bar is equal to A. Okay, so this is one of the rule, A double bar equal to A. Now second rule. These set of rules are associated with the AND gate. First of all, understand the AND truth table. 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. Why we are taking 4 combinations? Because there are 2 input variables A and B, and you know that the number of possible combinations is equal to 2 to power n, 2 to power 2 equal to 4. Okay, and if you remember, the symbol is, let's make me the symbol also, just for the revision purpose, it is a AND gate. For example, it is A and it is B and it is Y. So Y is equal to A dot B. A dot B. Let's do one thing. Let's find out what is the value of A dot A. Okay, A dot A. Now you have to find out what is the value of A dot A. Means if both the inputs are A, means instead of B, if I am having A, then Y is equal to A into A. Now A into A. Let's take, for example, take A equal to 0. Then 0 into 0 is equal to 0. And if A equal to 1, then 1 into 1 equal to 1. From where I am writing over here, just look into this thing. 0, 0, 0, 1, 1, 1. Okay, it means whatsoever the value is, the same value you are getting over here. Because now I am saying that instead of B, it is A. Okay. And for Y, 1, 1 is 1 and 0, 0 is 0. So A into A is equal to A. So it is equal to A. Next rule is A into 0. A into 0 is always 0. We know that if A is 0, 0 into 0 is 0. And if A is 1, then 1 into 0 is 0. So it is always 0. Now come to A into 1. Okay, A into 1. Now we know that whenever you are multiplying any number with 1, you are getting the same number. A into 1 is A. Whether A is 0 or 1, whenever you are multiplying the number, you are getting the same number. A into 1 is A. Now come to a value, you have to find A dot A bar. Now let's assume A is 0. If A is 0, it means A bar is 1. So 0 into 1 is 0. Okay, and let's assume A is 1. Now A bar is 0. 1 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0 means whatsoever the value is, you are always getting 0. So you will write here 0. So these are the 4 and related rules. Always remember these rules because these rules will be used while simplifying the Boolean expressions. So these are the rules. Complement and AND. After this one, next is OR rules. Now we will see what are the OR rules. Till AND rules we have seen that A double bar equal to A into A is A into 0 is 0, A into 1 is A into A bar is 0. Now we have to see that what is the value of A plus A is. A plus 0 is, A plus 1 is, and A plus A bar is. These are the 4 values that you have to calculate it. Again, take a, it is 0, 0, 0, 1, 1, 0, 1, 1. We are taking the 4 possible combinations of A and B. So, we know that 0 plus 0 is 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 is 1. Okay, so this is the case. Now, we have to find out that what is the value of A plus A. A plus A. Now, let's take A as 0. So 0 plus 0 is 0. Here you can see 0 plus 0 is 0 and 1 plus 1 is 1. Means whatsoever the number you are taking, you are getting the same number. Okay. It means when A is 0, because here instead of B I am taking A, when A is 0, Y is 0, and when A is 1, Y is 1. Means Y is just replicating the value of A only. Now A plus 0. Now again you have to take any value. A is this thing, 0 you are getting in 0, 0 and 1, 0. If it is A is 0, you are getting 0. If A is 1, then you are getting 1. Means the same value you are getting over here also. That's why it is A. Now see, A plus 1. This is A plus 1 means either this case or this case. And in both cases you are getting the 1 only. That's why 1. This is very important formula that whatsoever the expression is, if you are just adding 1, you are getting 1. Now A plus A bar. Let's take A as 0 and A bar will be 1. Now you have to add A plus A bar. Okay. A plus A bar is 0 plus 1, that is 1. And if you are taking A as 1, your A bar will be 0. So 1 plus 0 is 1. It means it is equal to 1. So these are the 4 important formulas, important rules for Boolean expressions. That is A plus A equal to A plus 0 is equal to A plus 1 equal to 1, and A plus A bar equal to 1. These rules will be used while solving any Boolean expressions. Just go through these rules. Then now I am starting with the laws, that is distributive law. After all rules, next is distributive property or distributive law. So in distributive law, it simply says A dot B plus C equal to A dot B plus A dot C. Okay. Now you can write it in 2 ways. Second way is A plus B into C equal to A plus B into A plus C. Now see what I have done. I have simply converted the AND into OR. Where the dot sign is there, I have shifted to plus sign. Where plus sign is there, just shifted to dot sign. This is the distributive property. So For example, a plus bc equal to a plus b into a plus c. After that, the next property is, or you can solve it also, that taking the values a, b, c, you can take it as a as 0, b as 0, 0, 0, 0, 0, 0, 1. Take the different values and prove these laws. Because now it involved a, b and c, means 3 variables are there. 3 variables means total 8 possible combinations are there. You can take the 8 possible combinations 0, 0, 0, 0, 0, 1 and so on, and then you can prove it, that when I am taking 0, 0, 1 and you are getting the same value that you are getting left side and right side. So in this way you can prove the laws also. Next is commutative law. So in commutative law, it is simple. A plus b is equal to b plus a. Or you can say a into b is equal to b into a. Okay, again you can prove it easily. You can take a different values 0, 0, 0, 1, 1, 0, 1, 1, and you can prove it LHS equal to RHS. It is commutative, COMMUTATIVE, commutative law. Okay, after it, next is associative law. Associative law is, it is just a dot b into c equal to a dot b into c, or you can write a plus b plus c equal to a plus b plus c. This is the associative law. Okay. So if I say what are the priorities, if you are having a Boolean expression, what are the priority? Priority is first of NOT gate you will solve, then AND, then OR. This is the priority. Okay. After this, the very important property is DeMorgan's law. DeMorgan's law says x plus y whole bar equal to x bar into y bar, or x into y whole bar equal to x bar plus y bar. This is a very important rule, DeMorgan's theorem, that has been used again and again, and you will use it while reducing the Boolean expressions. So this is known as the DeMorgan's theorem. For example, you are getting a plus b whole bar, you will simply get a bar into b bar. Means whenever you are having a combined inversion is there, you can split it using the individual complement and with the sign change. If it is in OR gate, you will get dot and point, and if you are getting the AND inversion, you will convert it to OR. This is a very important DeMorgan's theorem because you will use it again and again. X plus y whole bar is equal to x bar into y bar, and x into y whole bar equal to x bar plus y bar. You can represent by the bar form also and using the tick sign also. Both are having the same thing. So I hope it is clear. Now again you can solve it putting the different values in this same thing. Okay, when you will put the values, you are getting the same answers, and then you can prove that it is a right thing. Or moreover, you can take an example also. For example, you are having xy plus xy bar, and you have to prove it. If you have to prove it, what you will do, you can take a x common and then y plus y bar. And I have shown you in the Boolean rules also what is the value of y plus y bar. So y plus y bar is 1, x into 1 is x, so answer is x. So in such a manner you can reduce it any expression. Here you are using many gates. For example, you are using the AND gate again, and 2 AND gates and 1 OR gate is there, but here a simple value is there. So in such a manner the wires are less. Because the wires are less, you are taking a lesser power. If lesser power is there, your circuit will be fast. So just go through these laws and rules again, and then we will start with the practical problems of the Boolean algebra. Okay, this is the associative law, distributive law, and theorems are very simple. A plus AB equal to A. Just I have told you, take a common. When you are taking common a, it is 1 plus b, and we know anything plus 1 equal to 1. So 1 a into 1 is a. So you can do anything over here. You can find out the expression for any variable, means you can reduce it just putting the laws. Okay, just putting the different laws, you can reduce the expressions. Okay, you can easily see that here it is bigger thing and you are getting a smaller expression. And as the number of variables are less, because less wires will be used, understand this concept, because it is the main thing that why we are using the Boolean algebra or why we are reducing the expressions. The main thing is when you are having a bigger expressions with you, you are taking much more power. Your circuit will be much more complex. To reduce its complexity, we want to minimize it. We want to eliminate the redundant variables. So in such a manner, you can find out the values, or you can find out the expressions, or you can verify the answers just by taking the truth table. What will be there in the truth table? In truth table, just you will take the values of all the possible combinations. Okay, by taking the values of possible combinations, what you will do? You will keep putting the input variables at one side and output variables at the other side. And then you will see that it is equal to the both things, and then you can say okay, it is equal and our value is satisfied. So let's start with the practice problems of the Boolean algebra also.